I'm Nick Pandolfi.
I'm Stephen Lofton.
I'm David Smiger.
And I'm Nick Schubert.
And we're Team 2.
Alright, so the way this system works is we have our main base station here. This is essentially the main aggregator for the sensors we have composed around the house. So here, in a more direct, easy to access motion, we have sensor, which gets its ID of 3. It will speak with base station accordingly, just through a path. It does this through either a heartbeat to let it know that it is still active, and it will also use a data message, so it can inform them if the room is lit or not. On the other hand, if you're in an environment where you have obstacles such as walls, it can't route around it, or it's just too far for the sensor to reach, we have our relay that functions as a smaller aggregator for 2 sensors. Here we have sensor 4 and 5. These sensors alternate where the relay will check for both of them. So if we have sensor 4 here, sensor 5 go dead, then it will keep searching for this. Eventually it will time out. It gives up on this and only looks for the data on 5. It'll take the data from 5, take it into the relay, inform the base station it has something to transmit. Base station will give it a go-ahead, then the relay will send the data to it accordingly. The relay will keep checking on this repeatedly until the connection is reestablished. At this point, it will then cycle through 4 and 5 accordingly. Mostly this is set up through numerical paths, so it would go through 4, then 5. This is designed to avoid any kind of collision between the 2 sensors and to ensure that the relay can provide the data properly to the base station. Once the base station has all the information from the nodes, it then has the option to upload it to a system such as Cloud, with Firebase or ThinkSpeak. For this, we decided to resort to MATLAB for this for more easy, if you would call that, interface with the user. Alright, so in order to construct this system, it required a physical array to be constructed to confirm that this sensor system could work accordingly. We used available breadboards and wires that we could find within the lab of AK227, and as a result, we had a few troubleshooting issues that we were able to resolve, as you'll see in a moment.
Alright, so right now we're at 1.07, and the circuit doesn't want to work. So we're gonna hit it. Now it f***ing works.
Great job, mate! After modifying the system to not be so reliant on moments of physical encouragement, the system was then able to move into an operational stage. We confirmed the ability of this through the use of a serial monitor, as Stephen will now demonstrate. Any minute now.
Alright, so now on the serial monitor, we can see what the output of the network is going to be. It's in a waiting period right now. You can adjust how long it waits in between each time it tries to read. But here it sends a message from 1 to 2. It is polling the relay, and it gets 1 back. Now it's processing from 2 to 1. And it processed that the relay needs to send it 2 more messages. So got back a relayed heartbeat. This means that one of the sensors talked to the relay, and the relay responded to the base station. Gets back another heartbeat from the other one, confirming that we have a heartbeat from both of the sensors. Now it is trying to poll number 3. Now sensor 3 has been disconnected. It's not part of the network, so you see it polls a couple of times, doesn't get any response, and then just quits and move on. After the heartbeat, it's now moving on to trying to gather data. So it again asks the relay for data. The relay goes and asks one of the sensors for data, and it responds. Got back some of the relayed data, and now it goes and gets more of the relayed data. Both of the sensors in the network have responded with their data. It is now trying to poll number 3, which again is not here, so it will try a couple of times and then quit. The frequency and the delay on all of these can be easily adjusted. It's just a constant somewhere of how long you want to wait for a response. In this case, I think it's set to maybe 5 seconds per relay. It's given time to respond, and if it doesn't respond in that time, it's simply ignored until the next time data is requested. And then moving over, just for a brief view of the setup, here's our base station on a breadboard. This has the transceiver to communicate with the relay, which is right here, and this relay is paired with both of these nodes. Now, like before, this base station talks to the relay. That's where you're seeing 1 sent to 2. When 2 sends out messages, it is communicating with these 2, which both respond back, which aggregate with this red board, and the disconnected sensor is nowhere to be seen, which is what this guy pulls on for a while until it realizes it can't find data, and that's the end of that.
Great job, Stephen. You're making your country proud. Now that we know the system can function on a physical layer, we can advance into the MATLAB stage of the program.
Now right in the middle here, about 5960s, this area is when the light sensor was covered. These values can be easily adjusted. It's simply an analog read run through a resistor. We have a fairly small range, but that's simply because of the resistor values we chose. It jumps up a bit here, this 120, 130 range, when we're in ambient light. This is just with the light sensor laying on the table with the overhead lights lighting it. Here around the 200 range, 198, 205, this area is with the light directly on it. Notice this is a very small shift from mid-point between 0 and 100 to low 200s between complete darkness and very bright light, but again, this could be easily adjusted. This is simply done through importing the serial statements that you saw earlier into MATLAB and just pushing them straight to ThinkSpeak. It's a very simple API, and there's almost no modifications on the data done after that.